All right, so here's what we got. Let's review a couple. I'm gonna let you. We're gonna get lots of board work in today. So yesterday we talked about how to complete the squares. We're gonna practice just a couple of the key steps on that today, and then we're gonna move to like a new, shorter method, the other method, which is probably quicker to use to convert between forms. So let's get phones away, please. So if we want to, what we're really trying to do here is if we want to go from, in the process of completing the square, on the right side of the equation, when I have it in the form x squared plus bx, there's two things we got to be able to fill in. We got to be able to fill in what's the number that we're going to add to both sides. Got to do it to both sides, right? In order to make this a perfect squared trinomial that factors into using the same magic number twice. Okay? So what is the number, first of all, what's the magic number going to be? If the coefficient of x is b, what number always ends up being the magic number? No, half of b. Every time you're going to get, every time you know you're just going to get half of b right there. Half of b is always going to be your magic number. But to make that happen, the number that we have to add to both sides is half of b squared, right? Make sense? So that's what they're asking for here, is they're asking what's the number I have to add to these two terms to create a perfect square trinomial. Okay, why don't you put that pen up there? So for our problem, what are the values? Let's look at this problem 1. What is b to begin with?
1.
It's 1, isn't it? Right? It's the coefficient of x, which is 1. So if b is 1, then what is b over 2? In other words, half of b. Okay, but as a fraction, that would be 1/2. And then half of b squared would be?
1. No.
So if I square a fraction, that's really simple. If I square a fraction, all that is, so a over b squared, where a and b are just numbers, it's just going to be a squared over b squared. So 1 squared over 2 squared is what? 1/4. So I get 1/4. So the numbers I would fill in then, if I were going to go through this progression, we get x squared plus x plus something is equal to what squared? Well, 1/4 is the number I have to add to both sides, correct?
Correct.
To get the result, x plus 1/2 squared. Which answer are they looking for here? 1/4, right? They want to know what is that number. So the correct answer is 1/4. Okay? How about problem 2? We're just trying to figure out what's the number we're adding. What's b? Oops, 13/4. So what is half of b? How would I calculate half of a fraction? Multiply by 1/2, right? So there's two ways I could find half of something. If I want to know what half of 78 is, I could divide it by 2, right? And that's easy to do. Or I could multiply 78 by 1/2. Doesn't really matter for 78, but for a fraction, it's inconvenient to think about dividing a fraction by something. We always multiply by the reciprocal instead, right? So we get b over 2 is equal to negative 13/4 times 1/2. Well, look what I can do here. I guess I just multiply straight across, don't I? Now I can't cancel anything, and so I get negative 13/8. Agreed? And if I square that, I just square the top and square the bottom. What's negative 13 squared? Hey, Jack, we'll grab that.
109?
No.
Don asked you, Jamie, to set up the gym for J3. Once you guys are practicing. Okay.
What's that mean?
Like, set up the gym, the full gym to be ready for a basketball game.
So put
Put it
the,
on the chairs, about dimensions and make this.
oh, okay. Yeah, that's fine.
Thank you.
Yeah. thanks.
Wouldn't it be 149? Negative?
So what's negative 13 squared?
Negative 149?
169?
69. Oh.
Divided by 8 squared? Say it again? 64. There it is. That's what we want, isn't it? So the correct answer here is 169 over 64. Go to the boards real quick and try a couple of those for practice. There you go. Okay, so next one's a little easier. All right? Next question. So this time, listen please. Okay. So all they're wanting here is for us to fill in the next row. Like for example, with this first one here, this would be like saying on the right side, if we figure out what C is. So in other words, we're adding whatever number has to go there. What perfect square are we going to get? We're going to get what magic number that's going to give us the same factor times itself? Half of negative 31. We don't even have to figure out what that number is. We just know that we're going to get x minus 31 halves. And then the number that would go there is just negative 31 halves squared, which would be positive 961 over 4. But we don't care. Who cares, right? That's not even something we need to know in this case, because really all we're asking for is what's that factor going to be, and so we don't even need to know that thing, right? What's it going to be down here? These are really quick ones, right? So here we've got x squared minus 10/3 x plus something is equal to what magic number
3?
combined with x?
Negative or minus 10/3 divided by 2.
Okay, but it's a fraction, so we'll multiply 1/2.
So,
10, 6.
10,
Negative
6, so 3
10/6,
Negative 10/6.
which becomes, if I divide top and bottom by 2, 5/3. So there we go. Make sense? Okay, try one real quick.
Why did you have us sit down for that?
Oh, just 'cause. Okay, last issue. Last issue.
Go back up to the board afterwards?
Probably.
Yes, we are. So last issue now, we're gonna make this easier. So yesterday, we looked at the process of converting from standard form to vertex form by completing the square. That's complicated, right? That's a 5-step process. Why go through it? Well, because to learn things well, the way your brain works, you have to attach new information to prior learning. So it's like, for example, if you were trying to learn to play the guitar, if you had never touched a musical instrument before, that's going to be a whole different learning curve for that person than if somebody who had played other instruments, right? If you played other instruments, you'd have a lot of stuff you've already learned that would help you organize the information about playing the guitar, right? And so for the same reason, when you want to try to build up slowly this, as much as you can, this reserve of prior learning that's going to help you learn new material. So next unit, we're going to have to complete the square to solve some quadratic equations. So I made you go through it this unit, so you'd kind of be ready for it next unit, right? It fit into the context of what we're doing. Can you get by without it? Yeah, this way, right? There's a shortcut for doing the problems we did yesterday, and this is it. Instead of having to go through those 5 steps of completing the square, we could take a different approach. We could just say, okay, we know we're trying to go from standard form into vertex form, right? But vertex form always looks like a times the quantity x minus h squared plus k. If I just knew the numerical values, the numbers, to plug in for a and h and k, I'm done, right? So the other approach we could take is let's just calculate those numbers individually and plug them in, right? We already know that a is going to be, we already know that from standard form. We can see what a is, and it's the same value for a. What about h? Well, we have a formula, right? H is the x-coordinate of the vertex, and we find that by the formula negative b over 2a. So I'm just going to plug in some values of a and b and simplify, and I get a number answer, which I plug in for h. How do I find k? Well, I'm just gonna evaluate the function at h, right? K is the y coordinate. I find a y coordinate by plugging in the x coordinate into the function, right? And so I get back a number for k and I plug that in. So let's look at an example about something like this. And we've already done some like this. So it starts off in standard form. What are the values of a, b, and c in standard form? What's a? 3.
Negative 30 and 146.
Negative 30, and c is, who cares? We don't need c. We just need a and b, right? So we already know that I'm going to be plugging a 3 in for a. One of the 3 parameters, we already got a number, okay? To find the other ones, remind me real quick, how do I calculate h?
Isn't it negative b times 2a?
Negative, almost.
Over 2a.
There you go. Negative b over 2a. And if I plug in values and simplify, that's going to give me what, positive 30? B is negative 30, so negative b is the opposite, positive 30. 2 times a, well, a is 3. What's 2 times 3?
6.
6. 30 over 6 is 5. There's my second number I plug in, right? Finally, k. K is f of h, so in this case, I'm plugging in 5 into my original function. Every place I have x's, I'm opening up an empty quantity to plug in a 5. And what do I get? Now, here's a question for you. When I'm simplifying this first term, do I multiply the 3 times the 5 before or after I square? After. I've got to follow order of operations, and I have to do exponents before multiplication in PEMDAS, right? So 5 squared is
25.
times 3.
75.
Good. Negative 30 times 5, negative 150, plus 146. Well, negative 150 plus 146 is negative 4, plus 75, 71. I got it, right? So my answer then, if I plug all that stuff in, I should just get f of x equals 3 times x minus 5 squared plus 71. It is. Yeah, we did. I mean, we've done stuff like this already. We're just pulling in some parts that we already had in a different context, right? Okay, so try that one, please. Back to the boards. Yes. Yep.
Floor coat.
Whoops. Exactly, good. So one thing I can do is I can do 27 divided by 6, and then look what this does. Everybody look up here, please. Gabe, I need you up here too. So it gives me a decimal, but anytime it gives me that little button down there, it's a convert to fraction button. It only does that if it can be written as a fraction, and what do you know? It's 9/2. Okay, so we know that h is 9/2, so that's the value I'm plugging in, right? But I got to find k. So k is going to be a little tougher. If I want to plug k in, I've got to plug 9/2 in for all those x's, which I could do, but it's going to be a pain because I'm going to get fractions in there, right? So here's where you can use Desmos to your great advantage. So all you have to do then is we're going to come down to a new row, and remember this stuff. We haven't done it in a while, but I'm going to define the function f of x equals that, right? So we get f of x equals 3x squared minus 27x plus 65, okay? Now think what that does. If I type that in Desmos, I'm telling the Desmos computer that that's what f of x means. So if I plug values in for x, it's going to plug them in for x on the right side, okay? So if I want to evaluate that function at 9/2, all I have to do is go f of 9/2, and look what it does. It gives me an answer, which I can convert to the fraction 17/4. Does it for me, okay? So that tells me that k equals 17/4. So if I plug that in, I just get the result, f of x equals a, which is 3, times x minus h, which was 9/2, quantity squared, plus 17/4. And I'm done. Okay? Well, I'm probably tough doing this. But you get the idea, right? So just, you can use Desmos to make that process a little simpler when you're dealing with fractions.
Okay.
Okay?